if so, yeah.
Maybe I should maybe I should, like, I don't know. I mean, with the RPit stuff, but maybe I should first finish that. But I was also thinking that maybe I should start doing this seriously, not just attending to these
Well,
sessions. But
yeah, yeah, probably not a bad idea. I mean, there is the question of how to sorry, just seeing a message. I think there's the question of how much, to distract yourself, but my hope is that, right, over time, this is going to become like, it's a good way, not only sort of a key part of our process for modeling new language features, but also for like sketching the implementation structure, because pretty much all the hard problems surface at this level as
yes,
well,
yes.
right? The easy problems, so to speak, do not. Like what kind of pointer do we use and what's more efficient memory layout? No, that doesn't show up. But the like hard problems where you get stuck,
Right.
you have an inference variable here and you can't deal with it, that absolutely does show up. And so I think it's a great thing to be familiar with. I'm finding it much faster and easier to think this way.
Yeah. Maybe we
So,
should model RPT.
well, yeah, actually we should. I think we shouldn't right now because we got enough scope. I think the obvious thing would be to push on coherence stuff.
Right.
And keep working on that. Like, we could talk about negative trait impulse, which brings us to the question of what we do today. Hi, Dominic.
Hello.
Hi.
So I don't know if I know Dominic saw it. I don't know, Santiago, if you did. But over the weekend I implemented a new layer. So used to be, we had the logic layer. I realized I should name these with numbers or something, because right now they're in like a random order. But anyway, we had the logic layer, which had the type layer on top that defines how types work. The declaration layer, which sort of doesn't consider function bodies, but kind of has stuff at the function, everything else layer, and defines how you lower those into logic. The mirror layer that defines mirror type check and other stuff. And also, I guess interestingly, I don't know, there's sort of two things I realize now as I'm talking squashed into the mirror layer, right? There's like the mirror type check, but also the kind of top level checking, the main check function, which maybe should be separated itself out, because that includes stuff like coherence and so on. That doesn't really feel like part of type check. But anyway, there's those things. And then I added this extra layer called Rust. Hi, Will, totally relevant to you as well. And the main thing about the Rust layer is it's supposed to be the topmost layer, and the syntax and everything else is completely separated and corresponds as close as I could make it to actual Rust syntax. So like, as an example, here's the coherence check. Let me find a good example. Well, this will do. Like, this is how we declare a trait. Right. Trait A. So it looks. Oh, sorry. Give me 1 second because there's a fire alarm going off. Hopefully not anything serious, but I should investigate. Okay, my house is not burning down. Anyway, so it adds this this simpler syntax, which actually I was shocked what a difference it made in terms of writing tests, just so much easier. But that then gets converted. So let's see, where's an example? I would say this corresponds to in the compiler kind of AST or something. I'm trying to find an example. I guess this one will do. You know, this is a function foo with a lifetime parameter and a type parameter, and here's the input argument is ampersand tick at, returns ampersand tick at, the where clauses. Anyway, that gets converted in this lowering code into the lower layer. So like, it's mostly pretty boring, like lowering a function here, lowering a function declaration from the Rust-like syntax into the not less Rust-like syntax, mostly involves converting, like we convert the type into the lower version of the type. We convert the where clauses. And the reason I did this, besides making the test easier to write, is that I want to introduce some things at this level to simplify some of the other layers, because I found that like this decal layer was having too many concerns bundled into it all at once. And what I was in the middle of doing, but haven't yet completed, was changing there's a lot there. Let me try to. We used to have this idea, or we still do, of where clauses at this declaration layer, where a where clause is like close to the user syntax for things like Thai implements this trait, like tdebug. And then we also have the more lowered layer version. And then we have now yet another layer. The Rust layer has its own concept of where clauses, which is even closer to user syntax. So I was trying to get rid of this one and just have kind of chalk-like syntax and then user syntax that gets lowered away. And so far I'm having some problems doing that because some tests don't pass. And I don't know why. So one thing we could do is sort of debug why these tests don't pass, but that might be kind of not that informative. It's probably just me trying to find the mistake I made somewhere. So another thing we could do, yeah, so I guess I'm looking for suggestions on what to do. Another thing would be to talk about negative impulse, or maybe Dominic, you had something in your mind last.
Yeah, I had a short question about the converter project. Because like as we get closer to the Rust surface syntax with like a-mir-formality, like I do some of the work like from the lowering like in the formality, I do it in reverse, kind of in the conversion program, since I'm like using the rusty middle layer of things.
Oh, I see.
So, do you think it would maybe make more sense to use like HIR or something? But then we don't really have the types format we need, right?
That's an interesting question. So you're saying that at the point where you are in Rust C, some things have already been desugared, essentially, and you have to kind of reconstitute them, and other things not. Is that right?
Yeah, I mean, like it's not super hard. Like it's mostly like simple syntax things. Like for example, having ADTs versus structs and enums, stuff like that.
I think, yeah, that's interesting. I mean, we need to have the mirror, right? So we need to have access to the mirror in order to dump the function bodies. And I see you're saying about the types. My hunch is it's going to be better to do it where you're doing it, and to kind of reconstruct the syntax. If it's just structs and enums, it's probably worth the effort. If it gets more complicated, we should look into it.
Mostly just stuff I can skip. Also, for example, think like every type has this, or like the trait implementation have these bounds where it says like self implements the trait.
I see.
Yeah, but like, I mean, it's just a matter of skipping them, so it's not hard. I was just wondering if they're like, I'm too low already when converting, but it makes sense when we consider that we need a mirror.
I think you're at the right spot. I think we do want to eventually align Rust-C, like get the two more in alignment so that there's less, like each one of those conversion points is a potentially something we should try to fix. But to really bring the two into alignment, we probably have to actually model, take as input the here and model mirrored construction, right? That would, which I think we should eventually do, but I definitely don't want to bring it in scope right now. I'm thinking that exact example is an interesting one. Just, yeah, we add that as a sort of synthetic where clause, right? And is it every trait impl or every trait?
I think for every trait impl. No, wait, sorry, I'm not sure. I have to look it up.
I think it might be that we add that as a where clause either at the trait level or inside trait items.
Yeah, I think it's at the trait level. Like there is a trait has this var bound where it just says where self implements the trait.
Yeah, which is such a wacky thing to do. Probably not harmful. Anyway, okay, that's interesting. Because yeah, it's interesting that we don't have it. I think the reason we have it is because it's almost a convenience thing. Like I think we need it because when you're type checking a defaulted function body, you get to assume that self implements the trait. And
Okay, but we don't have that in formality since we don't have specialization.
yeah, we don't have defaults and we haven't hit that stuff yet.
All right.
But so that's a good example of like, I think skipping it is fine for now. I think eventually it shouldn't be there. There should be a, like, that's actually a bug that we should fix. I don't know which way we should fix it, but they should be the same. The set of predicates you get in Rust-C and the set of where clauses we. Okay. I'm not sure if what I'm saying makes sense. I was going to say the set of predicates you get in Rust-C and the set of where clauses. No, I think what I'm saying makes sense. Okay. I see your point. We're actually, because if you think of the Rust layer as being the AST, which is what I said, and this is sort of AST to here lowering in some sense, this lower to decal function, then you're generating from the here the AST, and that's the fundamental problem you're reckoning with. More or less. The mapping isn't perfect, but
so far it's not a problem, but it's just like a bit weird.
Yeah. I think it's something to keep an eye on. I don't know what I think the right answer is yet. But I do feel like we should eventually align these up and be able to generate from like one spot in Rust-C, which probably means more like the AST level, the input that formality expects. And like in the limit, it would be kind of cool if you could generate it, at different levels. Like we could generate the Rust level or the decal level so that we could compare, when you have a given Rust source, what does formality create versus what does Rust-C create and why are they not the same? That kind of thing.
Yeah, I mean, like that's mean, that's also an option to target different formality levels with the conversion thing.
Yeah, like we certainly could generate the decal layer. That would be more like the here.
Yeah,
But I feel like it'd be better if we generate this Rust layer,
depends
as long
on
as
what,
they're
like,
relatively close.
yeah. Guess it depends on whether the output should directly be fed into the like some like executed directly, or whether we want to like have the tests human readable.
Right. Exactly. I mean, the first thing that we do when we run a test, we just lower this, right? So like all the exciting code that we really care about is all working at the decal and mir layers, which is already lowered. So it's not crazy to generate the lowered version, but it's much more readable if we don't.
Yeah.
And some of the things like the types, I think, line up better with the Rust layer.
Yeah.
Okay. I say
Do
keep
you
it at
want
Rust
to-
layer and see how hard it is.
Yeah, well, I was already working on like adding that.
Cool. Are you going to open that as a PR against the repo itself?
Yeah, like the idea was to incorporate the like the generator into the main repo, right?
Yeah, I think that'd be great.
Yeah.
Okay. Cool. So with what time's left, why don't we do this? I'm gonna stash this. And maybe we can actually what I'll do is make a branch. Maybe we can do something exciting. We could keep poking on coherence, or we could
I have one more small remark about the Rust layer.
oh yeah, go for it.
Like in the lowering of the bounds clauses,
Yes.
where we have the projections. Do you think it would make sense to also lower that to a like implements per clause? Because like that is what happens in Rust, right? If we have the or if we say that I usually specify both, like the
Yes.
implementing and the projection.
Yeah, it probably does. I think that makes sense. We could do that pretty easily. Hold on. Like if we, I think this has all been merged, right? Come on. What is it? It's not called master anymore, is it? It's called main. Okay. Yeah. Okay. Good. Let's see if we do like you're saying like change this. So if we change this to return multiple where clauses,
Right.
and then this becomes 2 layers deep, which we can flatten. Oops, that one not there. Here. Is this what I want? What is this? Lower to decal, yeah. And then we could change this to be, so these are now all lists. And in particular, you're saying this one, we could include an alternative like var ID implements the trait ID. Like that.
Yeah,
Now-
that-
Now we know it implements the trait. And when projected, we get this. Okay. Let's see what happens. Should work. Although I noticed there's a bug. Yeah, this is that same bug. I've hit this before. I think this is a bug in Redux. You see how it's giving me this error, too few ellipses for pattern variable? That's just not true. But I found that I was able to work around it somehow. How did I do it? Sort of by breaking it out into its own thing, I think. Something like that. Uh-oh. Too many parentheses. Uh-oh. I don't know what I did wrong now. I don't. There we go. Okay. Not sure why that started happening. It's annoying. I should write Robbie. Anyway, in theory, this should work. The other option would be I think this is the right call, but the other option would be to sort of make it so that this one where clause. I mean, actually, this isn't really the right place to do it, is it? I don't think this is the right place. I think the right place is maybe more here, where we lower the where clause so that it would generate like, because if we do it in the bounds place, that means if you have something like type foo iterator item equals u32, we're going to get it. We're going to expand this to be like f iterator, where f is the type foo, and also f as iterator item equals u32. But if you have some piece of code like function foo f, where f, that doesn't apply. Because the bounds right now are only for like associated types, basically. See what I'm saying? So rather here, where we convert from the Rust where clauses into the internal form, here we could do it, and it would get both. But we'd have to modify this. Instead of taking one and returning one, it has to return a list, which seems okay.
Okay, I see what you mean, but on the other hand, we can write the like only projection thing in Rust surface syntax if we have where clauses, right? Maybe it doesn't make sense after all. But sure.
Right now, you can't, right? In Rust surface syntax, you only can write it in this form where you, like, we don't have equals,
Oh, yeah, right.
although we've talked about adding it. But I kind of, let's hold off. I think it might make sense, and this is probably where I would do it. But the other way to go about it is to say, if you know that this is true, that like if we know that we can normalize this associated type to this user type, make it like an implied bound that we also know that the trait is implemented, which is kind of how I expect it to be in the end of the day. Like
Yeah.
why it sort of makes sense to me.
Like from the perspective of converting Rust code to formality, I think we like at the level, like the rusty middle level, we already have like both clauses, right? We have the projection as well as the implement.
Yes,
The
in the
conversion.
middle layer we do, which is okay. We can run with
Yeah.
it. We should iron it out at some point, but. All right, well, I'm going to commit this, but I'm not sure that I want to merge it. Maybe we should, okay. So I'm going to pull up the repo because I want to do something. I don't know what I want to do, and share the share that. So like looking at the meta issues we have. Actually, this is kind of done, huh? Anyway, forget it. We could work on any one of these three things. Maybe, actually, why don't we do a little bit of the borrow checker stuff? I feel like that's a big unknown that hasn't made a lot of progress right now. Like, what does that even look like? Okay. Not hearing any concerns. So like, because right now we have the mirror checker, which does a bunch of stuff, checks function bodies, which runs the type check, which invokes the borrow checker, which is here, which does nothing at all. So I'm trying to remember why it's this way. It's kind of a hard. We have these goal at locations, which I think are in the extended grammar. Yeah, which has a location and a goal that has to be proven. So the first thing the borrow checker needs to do is actually prove each of them to be true, which is going to give rise to a set of constraints that it's going to have to solve. And if you remember, we have this type scheme idea. So when, which I'm trying to find a good test for or something, I guess is this extract scheme. No, how is this used? Yeah. Okay, so this helper function, tie prove scheme, says, this is really for writing tests, but it's a good idea. It says, given some environment and some variables that we bring into scope and a set of where clauses that we can assume to be true, we try to prove this goal and we get back a set of schemes, which are basically the solutions and additional constraints and things that apply. So like, to jump back, if we tried to prove, if we had a goal like, I don't know, back of question mark t out implements foo of tick where there was a impl foo of tick for a vec of ampersand tick u32, then the scheme might be essentially, first you would get a restated form of the original, if I recall. and then also the constraint. Sorry, it might be something like this. Something like there exists a B where a rec of A and tick B equals tick A or something. I don't know whether we would generate the equal sign, but that's the idea. So you get the main goal along with some variables that you can instantiate, and then constraints that when they're solved, make the whole thing true. And you actually get more than one potentially, because we don't deal with ambiguity very well in this code, but I'm going to ignore that for now. Does that make sense? Not sure how clear that was. But this is the structure of it. Here's the variables that are included. These are the goals that have to be proven. And that's the kind of restated version of the thing you were trying to prove in the first place. And from this, you can extract the value of inference variables and so on. It's not necessarily ideal. What you might rather do. So when you make a query, if you have unbound inference variables, you might rather we're kind of giving you back the substitution for those inference variables, but in a sort of roundabout way. Where we say, here's the original thing you asked for with the values of the variables in line, instead of just here's the values for the variables that we found. And I'm trying to remember why that was easier to do. I guess, but I don't think right. I think it's because we have this substitution. So the environment carries the final substitution, and we just apply it to the term, and we get back the new version of the term. But what we might rather do is extract, if we knew the set of variables, we can just find their final values. So, okay. So one thing about the borrow checker is right now we have the goals have to be proven at certain locations, but actually in Polonius, those locations matter, but in our current borrow checker, they don't. We just ignore the locations. We only care about the goals themselves. So let's start with this. We're going to start by extracting the goal location. We're just going to match them out. Let me just see what I wrote. Yeah, oh, it's location goal, not goal location. Okay. So if we match out, here's the location and here's the goal that has to be proven for each one of the things. Then we can actually try to prove them all. Right, we need to have a starting environment too. Is there an environment in this gamma? Do you remember? Let's find out. Gamma has no. So it has the crate declarations, the names of universal variables that are in scope, the function signature we're checking against, and whatever this is. I think that's the mirror of the function body. Confused. Where is this thing? Okay, it's the local declarations and the basic block declarations. Yes, so somewhere we instantiated these variable IDs as inference variables, right? They must have done. Probably here. So here's the function check from a-mir body signature, which includes existential variables, which we instantiated to get this environment. then we ran all this stuff. I think we have to pass this environment into our borrow checker, because it has the names of all our inference variables. Because now we can make one big goal, which is like all the goals have to be true. It's going to be annoying to debug.
Quick question: are there any free variables which are not inference variables?
There are, though there can be the type parameters on the function itself.
Right. Okay.
And those, but those we actually got those here. So this instantiate quantified mirror body sig, the mirror body sig itself has a for all with the generic parameters from the function, which we're going to instantiate with placeholders here, universal placeholders. And then we instantiate this existential thing here, and we get the inference variables. So we've got both inference variables and universal variables in scope.
Oh, I see. Thanks.
And then I think here, yeah, we don't have, this is interesting. What is this? What is this code? I don't think this is what I want. Prove goal, there we go. So we have this relation that says like, prove that this thing is true. This is really what we want. Although I'm going to make a new judgment. So call it that. Just to like add a layer of, not hard code this crazy long name. We're going to make this prove goal in environment relation. Which takes in an environment and the goal to be proven and gives out a set of an environment, right, in which that goal is true. And so then we have to import that stuff here. So then we can say like prove goal in environment in goal master environment out. And what's kind of annoying, but for now, let's run with it, is that actually we may get, like this could generate more than one result, right? There might be many ways to prove that goal true. That's okay, because it's actually the right thing to say if any one of them suffices. Now what's missing, like we can actually just stop here for a second. We should probably be able to make some tests, because what's missing now is that we're supposed to then take the, like this is going to yield a whole bunch of, we're going to have a whole bunch of inference variables for all the lifetimes and some relations between them, what outlives what and so forth. And the borrow checker would come in now and say, okay, if I'm mutating, like especially if it's Polonius style, if I'm mutating a variable and there's some live, starting at that point where the mutation occurs, there's some live reference which may have borrowed from that variable, then that's an error, right? But I'm just going to skip that part of the check, so not really doing the borrow check yet. But already this should do something, like, because what we did now was we type checked. Like before we were doing this type check goal, which was coming up with type checking rules, including a set of things we had to prove, but we were never actually proving them. And so we should be able to make some tests that like ought to have been rejected, but were not, right? And in fact, I'll just comment this out to prove it. Well, I'll keep these two because they should be true, but leave out the hard one. So let's do that. Let's make here's the test layer. Here's the basic function body test. So this was like our dumbest test ever that said I32, that allowed one I32 to be equal to another I32. So maybe I'll make like a type check. I don't know, I32 not subtype of U32. I think if we just change this, I don't know what's going to happen, but I think this code is going to not generate an error yet, because what should happen is we'll generate a goal to prove that U30 or the I32 is a subtype of U32, or other way around. Well, actually, I put this backwards. And that goal we'll never try to prove that goal, so we'll never see that it's a failure yet. Let's see. By the way, welcome Blitzer. If I don't think you've joined any of these sessions before, so feel free to speak up if you're like, wait, I have absolutely no idea what's going on, and we can try to loop in.
Yeah, maybe I need to like just watch for a bit just to get the feel of it, then I can ask questions. Currently, yeah, you're right. I have no idea what's going on.
Yeah, so the highest level view is, this is the definition of, or this endeavors to be, hopes to become kind of the definition of Rust in some sense, a formal model for Rust that is accepted, and that it does not currently include a bunch of things. It's kind of got most of the trait of a good version of the trait checker, better than Rust's maybe, but doesn't have a borrow checker yet, or some other parts. So we're poking at that, trying to fill in the borrow checker. But yeah, as you can see, well, so before that test passed, but before it said, so this test says, is the core crate okay? And it had true here. It should have false because we expect this to not compile. But it is passing, if I'm not mistaken. So if I run this test with false, I think we'll see a test failure. The other part of this that may or may not be obvious is this is being implemented in Redx, which is, oh yeah, there we go, which is a kind of dialect of Racket, which is a dialect of Scheme. So this weird syntax is all like Lisp syntax essentially, but anyway, I don't know. It's hard. You'll pick it up, or you will, hopefully. But in any case, this is our sample input, a function that takes an I32 and returns a U32. And this is the mir that we're type checking. These are the local variables in the mir. _0 has type I32, that's the return variable slot. _1 has type U32, that's the argument, first argument slot. And our one mir statement is to copy 1 into 0. And that should generate an error because I32 and U32 are not compatible, but it doesn't because this actual unexpected is backwards, by the way. That's because I'm supposed to be putting it like in the other order, but I don't because I like it better this way. Anyway, the point is we're expecting false, but we're getting true. So if we jump back into the borrow check, I think if we uncomment this line, should hopefully work. And what we can do is, for fun, let's actually we'll add the borrow check into this traced line so that we see what it's trying to do, what it gets as input. Okay, so indeed, we now get the test is passing, and you can see what happened, right? The borrow check judgment was invoked. This is the program definition itself, not very exciting, or not very easy to read. But this final bit here, this is the set of goals we had to prove. And that's kind of interesting. So at the first statement within basic block 0, we had to prove that U32 was a subtype of I32. That's what that says, which we failed to prove, hence compilation error. Woohoo. Try to prove or extend borrow check to prove goals from type check. Add a simple test that was failing. Or that I32 cannot be proven. I don't know. Let's make some more tests, I guess. Because I bet.
Could we have an inference variable and check whether it infers right?
Yeah, let's do that. Let's make one. Let's make a test. Let's say, well, okay. So if we have like, what about this test? Let x equals 22 ampersand x, no inputs. Yeah, this, we want this to eventually, this actually probably won't compile now that I think about it, even without the borrow checker, which is cool, but let's find out. So how would this look? So first of all, we have to modify the signature. We have this tick A. I need it because this is ampersand tick A 32. So that is a lifetime parameter A. We have no inputs. The output type is ampersand A U32. Underscore 0 here is now going to be ampersand A. This is the return type. This will be the variable X. This is where your tool would be handy. And then I guess we need a, well, no, I don't know if there's any more variables. All right, and the first thing we're going to do is initialize. Kind of forgot what our grammar looks like. An R value, an operand, constant is just a number. Okay. We're definitely gonna have to fix that, aren't we? But anyway, this should initialize, this should be like x equals 22. And then the return statement is like underscore 0 is ref, and here we go. We'll make, so there's going to be an inference variable, which is the lifetime of this reference. It's not mutable, and it's borrowing x, right? Which probably looks like, what does a place look like? Oh, that is a place, okay. That look right?
Could we also make, like, in the declaration of underscore 0, could the A also be another inference variable?
Because that's how it shows up in the desugaring.
Right.
Yeah, we could. That's a good point. If I think there's something which we may or may not be modeling that is supposed to be connecting the types
Right.
from the same. Yeah, okay. Yeah, let's try that. Now look good. Then I expect this is gonna, well, let's see what happens. I have no idea what this is gonna do. I think it's going to probably pass because I think we haven't included everything, which is kind of good. Let's rename this to something a little more interesting, like now that we know what it is, like return ref to local, for example. Also, I'm gonna put a new line here so it indents better. Yeah, okay, so this failed to compile, but I don't know why. And I didn't see any call to borrow check. So I'm guessing that it failed for some uninteresting reason, like some incorrect reason. So maybe what would be a good idea would be if we first make a version that should pass. That's usually a good place to start, and then make a variation that doesn't. Because one of the annoyances I find with this whole setup is that you don't really know why something didn't compile. But we're running short on time, so I guess what I'll do is let's maybe just for fun throw in some more tracing statements to see how far did it get. All right, so we see something now. So we got into check function body. Doesn't appear to have gotten very far through that though. That's kind of nice because that means at least we got the syntax of the mir correct. But like we didn't get to type check goal, so we must have failed the well-formed check, or maybe the unsafe check. Or I don't know why this is a where and not a where error. Oh, I suppose because this might be trusted function body instead. Okay. So yeah, it's failing the well-formadness check. Why? This is annoying. This check is pretty basic. So maybe we can just look real fast. Did we do something really dumb? _0 is declared, _1 is declared. I wonder if well-formed operand, where's that? Oh, that accepts const numbers. I don't know. Well, we'll stop here. We fixed at least one bug to start. What I can do is, I forgot to ask this last time. Are any of you who are currently watching interested in like picking this branch up and trying to figure out what's happening? Or or not. It's okay either way. But if you are, we could poke at it because I would rather hand it off to somebody and keep going back with what I was doing.
Yeah, I'd be interested.
Okay, cool. I will push it and ping you on Zulip and we'll pick up from there.
Cool. Yeah.
Thanks, everybody. Ciao.
Bye.
Thanks all.